So this second part of 3-2 should be pretty short. We've just got one little problem here, kind of one final aspect to add in, and this is actually going to help us transition into section 3-3, which is our next one. So what we're doing is kind of the same thing that we were doing for the first part. We're going to graph this system of inequalities, but what's going to happen is these are actually going to close off and form a triangle, and we're going to find the vertices, which are like the 3 endpoints of the triangle. So that's what we're looking at here. I put graph paper down. It's super, super, super important that you guys are using graph paper or a grid or something, because these need to be super accurate. You can't kind of guess, because you need to know exactly where these are intersecting each other. So I have graph paper. Just ask if you need it. So we're going to take a look at this first one. So equation number 1, so let's label these 1, 2, and 3. Inequality number 1, I guess, is in standard form. So we're going to find x-intercept and y-intercept. So for our x-intercept, what you do, remember, is you just cover up the y. So we cover up the y, divide both sides by 2, and our x-intercept would be -1/2. So we can start with that. And then our y-intercepts, if we cover up the x, we divide both sides by a -1, so we get +1 for our y-intercepts. Okay, so let's start with this one. So we've got a y-intercept of -1/2, so we're going to plot that. And then, x-intercept of -1/2 and a y-intercept of 1. So you can see here that we're going up 1 unit and over half a unit. So we can keep going up 1 over a half, up 1 over a half, or we can scale it and we can start going up 2 over 1. So this is super, super important that you're actually marking every single value that you can. So you can also go down 2 and then to the left 1. So from here, this would take you here, down 2 to the left 1, down 2 to the left 1. Again, super, super important, because when you're looking for the intersection points, you need to know exactly where they are. So this would be a solid line. We're going through all these points. Ignore, there was a spare point that didn't belong there. Just do your best to ignore it. And then we are going to do our test. We can test the origin because it's not on our line. So plug in 0, the whole left side becomes 0. So is 0 less than or equal to -1? Yes, it is. That's a true statement. So we're going to start by shading the region that does contain 0, 0. So that would be everything kind of to the right and below this line. So everything over here. All right, I know that's hard to see, but our final region will be like the overlap, so I'm going to get that really heavy. So number 2, we've got x plus y is less than or equal to 4. And so we're going to do the x and y intercepts for this one too. So x-intercepts, we just plug in 0 for y, so we end up with 4 for the x-intercepts. And then for the y-intercepts, plug in 0 for x, so our y-intercept is also 4. So we can plot 4 on the x-axis, we can plot 4 on the y-axis. This is a less than or equal, so we know it's going to be solid. And then if you look here, going down 4 to the right 4 is the same as going down 1 over 1, so you can mark down 1 over 1 all the way through. Again, it's super important that you're being really, really accurate, because we need to know exactly where all these lines are intersecting each other. So solid line, it goes through each corner right here. Okay, and then we're going to do a test. We can test 0, 0, so plug in and the whole left-hand side becomes 0. Is 0 less than or equal to 4? Yes, it is. So I'm going to shade underneath this whole region right here. Oops, broken crayon. All right, so we get that whole part. And then I'm going to do my third one. So this, I've got x plus 4y is greater than or equal to 4. So starting with my x-intercept, I plug in 0 for y, so I get 4. And for my y-intercept, I plug in 0 for x. So if I divide both sides by 4, I get 1. So same x-intercept right here, and the y-intercept is 1. I have the or equal to, so I know it's going to be a solid line. My slope here, I go down 1 to the right 4, so I can carry that on. So down 1 to the right 4 would take me like right there. I can also reverse it and go up 1 to the left 4, up 1 to the left 4. So connect those dots. Super, super important to be accurate because now I can see exactly where all the intersection happens. So I can test this one. Test 0, 0. Let's see what happens. 0 on the left, is that greater than or equal to 4? This time that is false. So I shade the region opposite of where the origin is. So instead of shading towards the origin, I'm going to shade away from the origin. That'll end up being over here. So my overlap between those three regions, like we mentioned, ends up being the triangle. And so we get this triangle in the middle. That's our overlap between all three of these regions. And the triangle is closed off on all sides. Like it doesn't go forever in any direction. So what we're looking for is the vertices. And that's these 3 points right here that mark the edge of the triangle. Okay, so let's start with this one. We'll label it. So this is right on the x-axis. This is the point 4, 0, because we didn't go up or down. So that's one of our points. This one right here, this is over 1 up 3. So the x value is 1. The y value is 3. That's another vertex, I'm sorry. This right here, that's right on the y-axis. This is the point 0, 1. We just went up 1 unit from the origin. So there are 3 points. We've got one of the vertex, another vertex, another vertex. So we've got 3 vertices there on our triangle.